Good afternoon to all. So today I will continue with your exercise 9.5 question number 4. So up to question number 3 we have done the factorization either by taking the common term, that is the simplest form of factorization, and then in third question we did somewhere the factorization by grouping or by rearrangement. Now in question number 4 you have to again do the factorization. So there are four identities which you can apply there. One is a plus b whole square, a square plus b square plus 2ab. Second is a minus b whole square, that is a square plus b square minus 2ab. Then it is a square minus b square is equal to a plus b into a minus b. So mainly you have to focus upon these three identities. Now the question is factorization. Factorization means everywhere I have to write my answer in this form, that is a plus b into a plus b. Now my question is given in this form. In the previous exercises we identified what is a and what is b and then we expanded that. Here we have to come back from this form to this form. If you can identify the given term, so I will pick the examples randomly from question number 4. There are 15 parts. You need not to be work out in hurry. Don't try to finish the things without understanding. I will give you the key ideas how you can identify and then choose the identities. Suppose I will focus today upon, let us see, a plus b whole square. So first of all, from question number 4 I will pick the questions based upon this identity and how to go for the factorization of that. But try to understand my point. Now your question will be given in this form if I am speaking about this identity. So I have to see that how many trinomials are there, because there are three terms in this expansion. So a square plus b square plus 2ab. So my question now is given in this form and I have to go back into this form. I have to write that in the form of a plus b whole square, so that finally I can write the factors a plus b into a plus b. Now what is unique there in this trinomial? You see a square and b square are the two perfect squares and all three terms are consisting of positive sign. So very simple to identify. In all these 15 parts you see which are the questions or their parts in which three terms are there and all three are positive. Out of those three you have to keep a watch upon their perfect squares. So which two are the perfect squares there? One of them you can take as a, another take b, and then write that as a plus b whole square, and finally you can write that as a plus b into a plus b. For example, suppose I'm taking your first part. You see, please pay attention to this and take your time. I am again saying, do not try to finish the things in hurry. You take your time. We have ample time available with us, because these chapters or their applications, these identities especially and their applications, will be required in coming classes also. So please pay attention to this. Now first part of your question number 4 is written as 4x square plus 12x plus 9. Now look at this, 4x square plus 12x plus 9. So what did I say? I said that there will be three terms. I have to work out. Today I am taking this identity. Suppose I will pick all the questions in these 15 parts which are based upon this identity and will train you how to go for this factorization. Now what I said, 1, 2, 3. Three terms are there. All three are carrying positive signs. Yes, it is. Now I have to identify what is A and what is B. So those two will be the perfect square. So if you see in these three terms, one perfect square is this and another is this. This is the perfect square and this is also the perfect square. So 4 is the square of 2 and x square is the square of x. So this is 2x whole square. The another perfect square you can see here is 3, because you know that 9 is a perfect square and 9 is the square of 3. So now this is A and this is B, and here if you see 2, AB, A means 2x and B means 3. Now you check, 2x whole square is what? 4x square, and 2 into 2 into 3 will make it 12, into x is there, 12x, and 3 whole square is what? 9. So a square plus b square plus 2ab is always equal to what? A plus b whole square. I mean to say what is a is, here a is 2x and what is b is 3, which I can identify only from those two perfect squares, what is a and what is b, and I have to write that if all three are carrying the positive sign, a plus b whole square. So a plus b whole square finally you can write as 2x plus 3 into 2x plus 3. That's all. This is factorized. So I hope you understand. Now your question is given in expanded form, and from expanded form you have to go back to the exponential form, and finally that exponent, the power is 2, so you have to write that in multiples of 2. Now let me take another example based upon the same identity, that is your a plus b whole square. So simply you try to check that what are the two perfect squares in such parts. Your then third part I am taking now. So if in third part you see, in third part it is 49b square, then it is 84bd, then it is 36d square. Again you see this third part is also based upon what? A square plus b square plus 2ab, because this is the a square, this is the b square, and this is 2ab. So one is this, another is this. Now you find out 7b. 49 is the square of 7, b square is the square of b. 36 is the square of 6, and d square is the square of d. A square plus b square plus 2ab means 7b into 6d. Now you see that 2 7s are 14, 6 are 84. Exactly 84 BD will be there. So finally what happens? A square plus b square plus 2ab. What is A now? 7b. And what is b now? 6d. Which two are the perfect squares? Those two terms especially are a and b. So this is a and this is b, because 49 is the square of 7 and 36 is the square of 6. So 7b plus 6d whole square, and your factorized form will be 7b plus 6d into 7b plus 6d. So that's all about your this third part. Similarly, another part based upon the same identity, I can take, if anyone is there, I think these two were there only. So I will stop here. Then I will go to the next one, that is your a square plus b square minus 2ab. Now second identity. So these two were based, one and third were based upon a square plus b square plus 2ab. Now I will pick the another identity, that is second one, which is there a minus b whole square. What is a minus b whole square? Is a minus b whole square is equal to a square plus b square minus 2ab. Now again you need to check how many terms are given. Your question will be given in this form and you have to go back to this form. In previous one it was a plus b whole square, now it will be a minus b whole square. Rest of the procedure will remain same, means two perfect square will always be lying, but out of three, two will be consisting of positive sign and one will be consisting of negative sign. So here is the example. Suppose I am taking now second part of question 4. It is 25a raised to the power 4 minus 40a raised to the power 2, 40a raised to the power 2 plus 16. So before doing anything, you see that how many terms are there? 1, 2 and 3. Out of 3, 2 are carrying positive sign and 1 is carrying negative sign, means that is lying in the form of a minus b whole square. And now I need to identify what is a. So 1 is this perfect square I can see here, another 16 you know is this perfect square. So 25 is the square of 5. A raised to the power 4 will be the square of a square, mind it. Square a raised to the power 4. If you will take a square here, so whole square will make it a raised to the power 4, and then 25 is the square of 5, and 16 all of you know is the square of 4. So 4 square is 16 and minus it is, so minus 2 a square plus b square minus 2ab. What is a now? 5a square. What is a now? 5a square. And what is b? 4. And multiply this. Minus plus minus into again plus will remain minus. 2 5s are 10, 4s are 40. A square is there, so a square. 4 square will be 16, 5a square whole square will be 25, a raised to the power 4. So means now this expression I have explained in terms of a square plus b square minus 2ab. Simply I am telling to you, you have to identify the two perfect squares and the signs, and then you write that in those perfect square terms, like this is 5a square whole square, 4 square, and here again 2ab means what is a, what is b, that you need to shift from here and here. And then a square is 5a square and b square is 4. This is line 5a square minus 4 whole square, a minus b whole square. So your factorized form will be 5a square minus 4 into 5a square minus 4. So this will be the answer for your second part of question number 4. Then suppose I am picking the next example based upon same is your fourth part. So fourth part of question number 4 given to you is, that is x raised to the power 4 plus 16 y raised to the power 4 minus 8x square y square. Fine. So here now you see again, this is the perfect square, this is the square of x square. Then 16 again is the perfect square for y, 4 is the square of y square only. So a square plus b square minus 2ab means minus 2a. What is a is x square and what is b is 4y square. What is b is 4. A is x square, b is 4y square. So here it works, and then you can check it. X square whole square is equal to x raised to the power 4. 4y square whole square is 16. Y raised to the power 4. Minus 2 4s are 8. Minus 8 will be there. X square into y square will make it x square y square. So a is this, b is this. So I will be there x square minus 4y square whole square. X square minus 4y square whole square. Now what happens? Here you see this is coming now x square minus 4y square into x square minus 4y square. But if you keep a check here, again these two are the perfect squares and are lying in the form of a square minus b square. So what you have to do, use this bracket, write it as x square. 4y itself is the square of 2y. Close it. Again it is x square minus 2y whole square and close it. Now this is a square minus b square means x minus 2y into x plus 2y. Again it is x minus 2y into x plus 2y, because power is 4, so x can be multiplied how many times? 4 times. So your answer will be lying x minus 2y into x plus 2y, x minus 2y into x plus 2y. So this is a question where I have to first convert it in the term of a minus b whole square, and then what is happening, I am getting a as x square and b as 4y square. So when I am writing, that is a square minus a minus b whole square, that is a minus b into a minus b. So here a is x square is a perfect square of x. b 4y square again is a perfect square of 2y whole square, means this form is now lying in the another identity, that is a square minus b square, which is always equal to a plus b into a minus b. So this is a is x, b is now 2y, because x square is the square of x and 4y square is the square of 2y. So x square minus 2y square, x square minus 2y square. So that is a square minus b square, a minus b into a plus b, a minus b into a plus b, and leave your answer here. And then the remaining part based upon this identity is your part number 5, that you try yourself, please. So first, second, third, fourth and fifth part you have to do yourself, and 3 or 4 parts I am giving you from practices point of view based upon these two identities only, that is a plus b whole square and a minus b whole square. Suppose you have to first you do practice that 81 a square minus, it is 126 a b and plus it is 49 b square. Fine, first is this. Second, you simply can do that is your 25x square plus 16y square plus 40xy. Third, you can try is, suppose I'm saying it is 9y square plus 36z square minus 36yz. And one more you can do is, that is 64 e square plus 100 q square plus 160 pq. So these four you can try based upon, two of them are based upon a plus b whole square and two upon a minus b whole square. So please do practice of these four parts, plus first 5 out of 5 I have done 4, then remaining I will start tomorrow. Thank you.